So a question you may be asking yourself at this point is, all right, so my hard drives are no longer inside my servers, but my servers have to come online and somehow boot an operating system. So where do they get that information? Well, we have a lot of different options that are going to center around that, and these will be known as what we call boot options. Now, we might look at a local boot option. We might actually still have a local disk, or we might actually be able to boot off of the network. That is a capability within UCS. However, as you can imagine, there's going to be a little bit of configuration around that. So let's take a look and see how we do this. So here's our problem. We have a server that is diskless. It has no local storage, and yet we need to boot up. We need to access wherever our operating system is stored, or possibly our hypervisor. We installed this somewhere, so we've got to be able to come online, and how exactly do we go about finding this? We have a lot of different options, the first of which, by the way, would simply be a local boot. We could actually configure a very small amount of storage in this server, and it could have what we call the boot drive. The boot drive could be as small as an SD card. Or if that's not large enough, then we could deploy a hard disk drive or possibly an SSD, and usually we want to deploy 2 of them for redundancy, so we'll do a very basic RAID between the 2. And UCS will support all of this. Our B200s, for example, they can support an SD card, or they can support 2 drives in the front. And this, by the way, is the primary reason why a Blade supports 2 hard drives. For the most part, we're not going to be using that for a whole lot of local applications. We don't get a whole lot of I/O out of simply 2 drives. However, we can boot off of this. And so that's what we might see deployed in a lot of our data centers today. Now, the other option is we could actually go out onto the network and try to find a data store that has our operating system there, or again, our hypervisor. In this case, we still call this a boot drive. However, the boot drive is now stored on the network. So how exactly do we go about going out and finding this? Remember, our server is booting up without an operating system. It hasn't loaded Windows or Linux yet. And so it can't do a whole lot on its own, but it can actually do this much. But that said, because the operating system isn't up yet, this is going to be performed in BIOS. Now, if BIOS is involved, then you can imagine that this is going to require some configuration in UCS Manager, and that is indeed the case. Now, the way we accomplish this inside of UCS Manager is going to be inside of the service profiles, and specifically a policy that we create called the boot policy. We'll be seeing the boot policy and a lot of different policies in more detail in future videos covering service profiles. But for now, let's understand that the boot policy is going to list out the order in which we attempt to boot up. We can have a lot of different options available here and configured. For example, the first option in a lot of cases is going to be an optical boot. We might specify to look for a CD or DVD and boot from that. Now, this is hearkening back to the days where there's an actual optical drive on our server, and if we wanted to bypass the traditional boot, we could insert a DVD in there. Maybe it's a Windows DVD, and we're going to reinstall the operating system. And so we insert the optical disc inside of there, we boot it up, and it knows that, hey, if there's a DVD or a CD inside of the optical drive, then I should look there instead of booting from my local drive like I normally would. Well, we can create the exact same thing in the boot policy. We can specify to look at CD or DVD, the optical drive. However, the problem with this is we don't actually have an optical drive on any of these Blades or any of these C-Series servers for the most part. That said, we can do this virtually via what we call the KVM over IP session. We can actually virtually mount an ISO, which is basically a virtual CD or DVD image, and we can boot off of that. And so we could still tell the server, even though it doesn't have an optical drive, to boot off of a local CD or DVD, which at that point would be presented to it virtually via UCS Manager. Now from there, we could look and say, all right, we want to boot locally, and we'd point it to the local data store. So maybe it's the SD card or the SSDs or what have you. Or we could say, you know what, we're not going to boot locally, we're going to boot via iSCSI, or we're going to boot via Fiber Channel. Now, if we're going to boot via iSCSI or Fiber Channel, there are a few things we need to know. First of all, let's talk about iSCSI. We mentioned in the last video that there is such a thing as an iSCSI VNIC. However, I warned you that the iSCSI VNIC is not how we traditionally deploy iSCSI into our data centers. We would simply deploy a standard VNIC and present that to the hypervisor connected to the vSwitch and do everything that we showed in the last video. The iSCSI VNIC is all about booting from iSCSI. And the reason we need this is because, remember, we haven't booted the operating system yet. It is not going to even see the VNICs that we've presented to it. As such, UCS needs to spin up a VNIC that can gain network access without the operating system. The iSCSI VNIC will be configured with an IP address. And furthermore, our boot policy is going to specify a destination address. And so when our physical server boots up and it lacks local storage, it's going to check the boot policy, and maybe we'll say, okay, well, do we have an optical drive attached? We do not. All right. So we move on to the next one, and it says iSCSI. And it says to use this IP address and effectively go out to this destination, which is our storage array, to find the boot drive. At that point, it can download the information, it can boot itself up, and at that point, we're good to go. We don't actually need the iSCSI VNIC anymore, and as such, the iSCSI VNIC will never show up to the operating system or hypervisor. Now, one thing to note in all this is that the iSCSI VNIC is what's known as an overlay VNIC. I just mentioned that it's not going to show up in the operating system, and the reason for that is because it's not truly a VNIC that shows up in our service profile configuration. Instead, it's going to overlay itself on top of an actual VNIC that has been created. Remember, the VIC is configured in hardware, and so the VIC has been already configured by the service profile, and therefore the VIC has a VNIC that can be used. It just, again, it's not configured by the hypervisor yet at this point. And so UCS will take advantage of that by deploying the iSCSI VNIC on top as an overlay on top of this VNIC, meaning that this VNIC needs to be in the proper VLAN and have the right settings that will support our iSCSI connectivity. Next, let's talk about fiber channel. And by the way, we can leverage FCOE as well, so either one can be used. Either way, we are going to specify a virtual HBA that we're going to use. Remember, we only have 2 VHBAs. So as part of our policy, this is one policy we're creating, we actually get to specify the primary VHBA, and we get to specify a second virtual host bus adapter. Now from here, we actually get to specify 2 different storage targets per VHBA. In other words, we have a primary target and we have a secondary target. And then we can do that for the second VHBA as well. We have a primary target on that fabric as well as a secondary target. Now the assumption here is that we have something like this, that our server's booting up, we've got these 2 different virtual HBAs that we can use, and we go through the fabrics, through the fabric interconnect, and at some point through the storage area network, let's just draw both of these fabrics at this point, FI on the right, connection down. Now we have a storage array up here that has 2 connections in to each fabric. This is a pretty typical configuration. We want the resiliency of 2 connections on a per fabric basis. And so fabric A will have 2 connections to the storage array, fabric B will have 2 connections, and this is why we have a primary and a secondary connection type. So assuming we pick fabric A as our primary and fabric B as our secondary, what we're going to do is we're going to tell it to, hey, try to reach out to this interface first, then try to reach out to this interface, and then if all that fails, we'll switch over to the other VHBA, and we'll check fabric B's interface here, and then fabric B's interface here. It gives us 4 different opportunities to try to connect to the storage array and attempt to boot up. Now again, we're going to take a closer look at boot options as we go into service profiles later on in this course, but for now, what we primarily want to understand is that we can boot across these different network configuration types. So first of all, we did see that we can support local boot options. It's not really the scope of this skill, but at the same time, let's recognize we can boot off of a local SD card. We can boot off of local hard disk drives or solid state drives. So that option does continue to exist. However, we can also boot across iSCSI. We take advantage of that iSCSI VNIC. Remember, it's an overlay VNIC, meaning that it'll basically use the connectivity of an underlying VNIC, but when the operating system actually establishes itself, it's not going to see that iSCSI VNIC as being physically attached. Now the fiber channel, we can use that as well, and the fiber channel boot is going to specify the 2 different VHBAs. We have a primary and a secondary, and each one of those gets 2 different paths out to the storage. So we can specify primary and secondary for one and primary and secondary for the other. The idea here being, of course, that it's very important that we boot up, that we have access to our boot drives. We need that in order to form the connections and boot our servers. I hope this has been informative for you, and I'd like to thank you for viewing.